This video will be part 1 of lesson 2, and the lesson is on page 399 of your student workbook, and it's called The Relationship Between Two Quantities. Okay, first word that I want you to highlight is this word relation. And what a relation is, it's a mathematical relationship between two quantities or between two sets of data. Okay, so a relation is a mathematical relationship between two sets of data. In mathematics, a comparison between two sets of element or two sets of data is called a relation. So an example for class example 1, it says list an example of a relation. So a real life example of a relation is the money earned working. So the money that you earn working. So the money earned working, what would that be related to? How much you get paid is related to what? So the money earned working is related to the number of hours worked. Is related to the number of hours worked. That would be a relation. Remember that we have two axes. This would be our y-axis and this would be our x. And money goes on your x-axis and time goes on, sorry, money goes on your y-axis and time goes on your x. So time would be the number of hours worked. So 0 hours, you'd make $0. 1 hour, 2 hours, 3, 4. And then how much you get paid an hour. So let's say it's $10 an hour. So if you work 1 hour, you get $10. And if you work 2 hours, you get $20. 3 hours, $30, 4 hours, $40. And in the last podcast or in the last lesson, we discussed, does it make sense to join the dots? So with hours, does a value exist between 1 hour and 2 hours? So can you work, for example, 1.5 hours and get paid $15? The answer is yes. So if data exists in between points, we will connect the dots, and that's called continuous data. Okay? What we're going to be looking at is two more terms called the independent variable and the dependent variable. So we know our Cartesian plane as, well, the horizontal axis is my x-axis and the vertical axis is my y-axis. Now what I need you to know is that your x-axis is also called the independent variable and the y-axis is the dependent variable. So basically what that means, if I was to go back to this example here, so the hours worked is my independent variable, the money is my dependent variable. So how I would read this is I always start with the y-axis and I would say, okay, the amount of money earned depends, right? It depends. What does it depend on? It depends on the number of hours worked. Okay, so the amount of money earned depends on, and then you go to your x-axis and you say, well, it depends on the number of hours worked. So dependent variable, independent variable. Then so you need to know, like I said, the term independent variable and dependent variable. The x we also call the input, and y or dependent variable we call the output. And that's what this entire lesson is going to be on is, well, what does this input mean, output, independent, dependent variable? How does that work? Okay, so flip your page. And what this is just going to show over here is different ways that we could represent relations. So these are different ways to represent relations. Okay, and we're going to be doing all of these different ways in this unit. So the first is a table of values. Your input, remember, is your x values, and your output is your y values. From here, remember that your input is your independent variable and your output is your dependent variable. Now, this makes ordered pairs, right? So this, if this is your x and that's your y, and you put a comma in between, you get an ordered pair, right? So this would be 30, comma 9.1 gives me an ordered pair. 40, comma 8.4 gives me an ordered pair. Then, from either a table of values or ordered pairs, what can we do? We could graph it. And on our graph, we always have our x-axis, stab your x through the heart, and here's our y-axis. Though they want the letters to be different, so I look and I say, okay, well, what do they want my x letters to be? And x, they want to be the letter S, right? So this is S, speed, and they want my y to be cost, right? So that's why they put cost there. Then they have something called a mapping diagram. And I'll show you mapping diagrams later, but they're super simple. How a mapping diagram works is it's sort of two eggs. That's your x egg, and this is your y egg. In your x, you put all of your x values. So if I went to this table here, I put 20, 30, 40, 50. So 20, 30, 40, 50. And so that's your independent variables, your x values or your input. This would be your output or your y values or your dependent variables. So I'm going to have 10, 9.1, 8.4, and 7.9. So 10, 9.1, 8.4, 7.9. And what you do, the coordinate would be 20, comma 10, right? That's our ordered pair. So what mapping works, how it works is 20 gets mapped to 10. And 30, they want mapped to 9.1. 40 to 8.4. 50 to 7.9. And I could write all of these in my x, all of these in my y, map it, and I would get this. We are going to skip this example here because in this unit, we don't have to deal with squared functions. So we're going to skip that class example. And here they're talking about independent and dependent variables in a relation. So remember, draw yourself a little Cartesian plane and label it. So stab your x through the heart, extend your y down. Now, remember that y is your dependent variable, and that depends on whatever your x is, which is our independent variable. And then we also need to know, like I said, the input term and output term. So x is always our input, and y is always our output. They give us an example down here. So here's an equation. Y is equal to 3x minus 5. So I want you to do a few things. I want you to set up a table of values, and we're going to put x over here and y here. And then we're going to graph this, and then I'm going to show you actually how to do this on your calculator. So on my Cartesian plane, there's my x values, and here's my y values. Okay, they give us an equation. Y is equal to 3x minus 5. So I'm going to write that equation down. Y is equal to 3x minus 5. Remember that x is your input. What that means is I could pick numbers for x, and I'm going to pick the numbers 0, 1, 2, and 3. And I could input those numbers in for x. And whatever the answer is, that's my output. That's y. So I'll show you what I mean. Let's input 0 here. What would my output y be? 3 times 0 minus 5. Y would be 3 times 0 is 0 minus 5. Y would be negative 5. that's my output. If I input 0, output is negative 5. Let's do input 1. So y is equal to 3x minus 5. Y is equal to, I'm going to input 1. 3 times 1 minus 5. That would be 3 minus 5. My output, which is my y value, is negative 2. If I input 2, so if I input 2 there, 3 times 2 is 6. 6 minus 5, my output is 1. And let's do the last one. I'm going to input a 3. So 3 times 3 minus 5, that would be 9 minus 5. My output, or my y value, is 4. Now, once you have this chart, what can we do with this chart? Well, these make ordered pairs, and I could graph them. So on my grid here, I'm going to have 0, 1, 2, 3, 4, and 1, 2, 3, 4. Oh, and it looks like I need to go into the negatives. So negative 1, negative 2, negative 3, negative 4, negative 5. Okay, this point here, if I said graph this, you would say, okay, my x is 0, my y is negative 5. So where's that point? X is 0, y is negative 5. This point here is 1 comma negative 2. So x is 1 and y is negative 2. This point would be 2 comma 1. So 2 comma 1. X is 2, y is 1. 3 comma 4, x is 3, y is 4. Now it's sort of hard to see because this isn't to scale. If I drew a line though, here, all of my points should lie on the line. Like they would lie on your line. This is what we call a linear relation. It makes a line graph. But because it's not to scale, it looks like that guy's slightly off. But if I did this on a sheet of grid paper, everything would be on there perfect. Okay, so again, input versus output. Oh, let me show you how to graph this. 3x minus 5. So this is where the fun starts. You need to be able to graph this by hand, but let me show you how to graph this on your calculator. So how you would graph this is go to y is equal to, and I'm going to delete this math 30 stuff, and I'm going to type in 3. Here's your x button. It's right next to your alpha button. 3x minus 5. Then you hit graph. My window is way off. So how you go to a normal window is you hit this zoom button and you hit zoom 6. And what this does is it graphs it. This is a 10 by 10 window. So this x value, there's 10 hatch marks, negative 10, negative 10, and y goes up to 10. So let's compare and look at that. It does look pretty good. Then what's even better is you could get a table of values from here. So we know that when x was 0, y was negative 5. Like we calculated all this, right? Let's double check that I was right. Second function, and you're going to hit graph because you see above it says the word table. And look at this. Here's your table of values. When x is 0, it says y is negative 5. When x is 3, y is 4. So when x is 3, y is 4. I could say to you, well, what is y when x is 7? So when x is equal to 7, you could plug it into the equation. Y is equal to 3x minus 5. So let's see what we would get. Y is equal to 3 times 7 minus 5. Y is equal to 21 minus 5. Y is equal to 16. So I could do it that way. Or how else can I do it? I could look at my table of values, and when x is 7, y is 16. Or the last way you could do this, I might have to change my window. Let's see if it works. If I do second function um, calculate, so it's the trace button, number 1, if I type in x is 7, look at that, y is 16. I'll show you again. Second function, calculate, which is the trace button, a value. I could give you any value I want. What is y when x is 25? Oh, it's out of my window. That's why it's not doing that. So let's try a different one. Graph, second function, calculate a value, number 1. When x is -3, when x is -3, y is going to be way down here at -14. Okay? Class example number 2. The diagram shows relations expressed in different ways. In each case, state the independent and the dependent variable, the inputs and the outputs. How I always like to do this is as follows. This is always my x, that's my y. And my x is always my input, and my y is always my output, right? This is x, that's y. It's always x, comma, y. So x is my input, y is my output. X is my in, y is my out. Oops. In, out. So if they want the independent variable here, the independent variable is letter P. The dependent variable is letter Q. The inputs would be these guys here, 5, 8, and 11. And my outputs would be 10 and 16. Okay, going to this class example, my independent variable is always my x, dependent variable is always my y. So according to class example B, my independent variable is V, probably volts. My dependent variable is A, amps. Then they want my inputs. So they're going to input a 4, a 10, and a 25, and they want the outputs. When you input a 4, a 15 will spit out. When you input a 10, a 12 will spit out. And when you input a 25, a 15 will spit out. Okay, they've listed it as ordered pairs. So remember that input, output, independent variable, dependent variable. So IV and DV. So B is my independent variable, and C is my dependent variable. And then my inputs are all of my X values. So 3, 4, 5, and 6. And my outputs are all of my Y variables. So when I input a 3, a 7 spits out. When I input a 4, an 11 spits out. When I input a 5, a 15 spits out. Input a 6, 19 spits out. Okay, one thing, if I gave you guys an equation, y is equal to, the equation we did was 3x minus 5, I think it was. Just remember for input output, so you know that x is always your in, and that is your independent variable. Y is always your output, that's your dependent variable. Okay, so x is input, y is your output, what spits out. Your input is always independent, and your y is your dependent. So according to this, it says state the independent variable. So I know that the independent variables in my equation, so it would be the letter R, would be my independent variable. That's my input. And my output is my dependent variable. That would be C, dependent variable. Okay. We know that this is my y-axis and this is my x. They're just using different letters. And I know that my y-axis is my dependent variable and my x-axis is my independent variable. So when they say, well, what's your dependent variable? Height. That's on the y-axis. What's your independent variable? Time. C, the amount of sap, S, obtained from a maple tree is dependent on time. Okay, so if I was to graph this, um, SAP is dependent. So dependent variable is always here. Independent variable is always here. So they're saying that the amount of SAP obtained depends on time. And time, remember I said it's always on your your x-axis. So what this would be, SAP would be my dependent variable, and time would be my independent variable. Okay? So make sure that SAP, is dependent and time is independent. For homework, I want you to do questions 1 to 4. So question 1, 2, 3, and 4. And then when you're done that, you could upload part 2 and finish off this lesson, which has one more part to it.